Hello everybody, welcome to my channel. This is my new video. In this video we are going to discuss this voltage gain with how to find voltage gain without small signal analysis. That's very important. This is a second part to the this is the second part. So if you didn't view the first, if you don't view the first part, then I will give that link in the description. You can watch. So before that, kindly subscribe my channel because it will be a huge a benefit for me. Kindly subscribe, and if you like this video, just like it and share it, otherwise dislike it. And if you have any doubts, then ask it in the comment section. I will clear it. So let's start. So first of all, what voltage gain? What is voltage gain? That is output voltage by input voltage. So normally we are using small signal analysis to find voltage gain of some BJT circuits or MOSFET circuits. But today I am going to discuss with you the method which I didn't see this method in any textbooks. So I will share with you now. So in this method, what we have to do is we have to consider the output loop, and for output loop as well as input loop. So for example, consider this figure. In this this is a common emitter amplifier. Why this is common emitter amplifier? Because input is applied. This is AC analysis only. This is not DC analysis. This is AC analysis. So here input is applied at a base and output is taken from collector. So emitter is common. That's why emitter is common. So this is common emitter amplifier. And first point to be noted is that if it is a common emitter amplifier, voltage gain will be negative. Okay, otherwise it will be positive. That is in common base as well as common collector, it will be positive. So whether it is a common emitter, common collector, common base, in the input loop we have to find some resistance, and output loop we have to find resistance. And what we have to do is just divide this by output loop resistance divided by input loop resistance. That's all. So what we are going to do is, here the input resistance will be this RC only, V out. This VCC means ground. In AC analysis our DC voltages will be ground, so this will be RC only. So here output resistance, output loop resistance is RC only, divided by input loop resistance. Input loop resistance is, we have to always, this is second point, we have to always go from emitter to base only. So while going from so we have to always go from emitter to base. So here emitter to base we are seeing a resistance 1 by GM, that I have told it in the first video. So you can watch that video. So actually transistor is just equivalent for resistors only. So we can consider it as a resistor 1 by GM. So we have to divide it by 1 by, so we have to divide input loop resistance, it is 1 by GM only, and we have to put a negative here. So minus RC by 1 by GM, that is minus GM RC. So within seconds we can make this, we can find this. Otherwise we have to do small signal analysis. We go for second example. So applying the same rule here in the output loop that is RC only. So first we have to check whether it is common emitter amplifier. This is common emitter amplifier, so negative here. And in output loop there is only single resistor RC, so here this is RC only. So RC divided by, here there is an emitter resistor RE, feedback resistor, so we have to include that also, RE plus 1 by GM, that is the input resistance. So RE plus 1 by GM. So RC divided by RE plus 1 by GM. Okay, this is voltage gain. And next example is this. This is a PNP transistor. Rest of us previous two examples are NPN transistors only. This is a PNP transistor. PNP transistor also there is no difference, same only. Here this is emitter, this is collector, this is base. So we have to look from collector to emitter to base in to find the input loop resistance. So here there is an RE plus 1 by GM, that is input loop resistance. So we have to write Re plus 1 by Gm, that is input loop resistance, and this is common emitter amplifier only, so we are putting negative here. And in the output loop we can see that from collector we are taking the output, and here we are connecting a transistor as a load. So this transistor can be replaced by a resistor. This so the equivalent resistance is this equivalent resistance is equal to R pi plus R pi parallel to 1 by Gm, that is it's the equivalent resistance of this transistor. So this is just acting as a load only. So here total resistance will be RC plus R pi parallel to 1 by Gm, that is I have written here RC plus R pi parallel to 1 by Gm. Okay, I hope you understood this. Here this is just a load only, we have to replace it with a R pi parallel to 1 by Gm. And how this came, I have discussed it in the first video, that is part 1 video, how to find the input resistance. So just look that video, you will get that. So within seconds we can find anything. We can find this voltage gain also. Similarly we can find this will work for this will work for MOSFETs also, and differential amplifiers also. This will work, but there are some modifications there. And similarly we can find output resistance also, same some modifications are there. So so if you want the next part, just comment under this video, so that I can make that video. So kindly subscribe my channel if you like this video. So thank you for your support. Thank you.